Yeah, good afternoon, students. So today we will discuss about the voltage regulation. So in this voltage regulation, you have to know about that how do you regulate the voltage here. So somewhat you can easily observe that there should be a fluctuation. It should be takes place in the case of a voltage. So if the fluctuations it is to be noted in the case of voltage, you can easily identify that the current is also going to be varies. So how you are going to be regulate, that means how you are going to be stabilize this voltage. Okay, so in this uh, chapter we have to discuss about that what is the need for the voltage regulation and what are the characteristics which is to be needed here to regulate the voltage here, and how the Ginnar regulator, that means how the Ginnar diode which is to be utilized to regulate the voltage here, and also shunt regulator, and later on electronic regulator, series regulator, and versatile variable voltage regulator. These are the different types of voltage regulators which are to be available. So here most probably we are to be utilizing here a GNR regulator here, and later on fixed voltage IC regulator here, and finally the switching regulator, that means the switch mode power supply. So here the thing is that here the circuit description about the SMPS, switch mode power supply, and what are the advantages as well as the disadvantages of the SMPS, and the theory of the switching regulator. Okay, so today we will discuss about the what are the objectives of this one. Now we have to discuss about the what is the need of the voltage regulation here. So somewhat in our home appliances, there we are to be utilizing here AC supply here. There only the fluctuations which should be takes place here. How do you stabilize this voltage when the fluctuations which is to be takes place, when the higher voltage which is to be coming out, there only we are to be utilizing here step down transformer. When the lower voltage is to be coming out, there only we are to be utilizing here step up transformer. So here in primary, all these are to be take place, whereas in the case of a secondary, the stabilized voltage which is to be supplied to this here home appliances. So that what is the voltage which is to be sent here 220 to 240 voltage with a 50 hertz frequency. Okay, so the thing is that here if you use a rectifier, so that means a rectifier means which can convert the AC into pulsating AC into a DC supply. So along with that, here what is the filter? That means along with the DC, the entire AC which is not to be converted into a complete DC here. If you use this half wave rectifier and as well as the full wave rectifier here, how the efficiency of the full wave as well as the half wave rectifier which is to be calculating, we already discussed 40% compared to the top the 121% here. Okay, so that is to be enhanced by using the single rectifier into a double rectifier, that means one diode into a two diode. So before discussing all these things here, you have to know about that what is a PN junction diode. In forward bias, the diode which is to be conduct the current, when the voltage is increases, the current is also going to be increased. So in the reverse bias, the voltage increases, the current is not going to be conduct. Okay. So in this case, here, why do you consider here a GNR regulator? That means why do you consider a GNR diode which is to be here stabilizing the voltage here? How it is to be stabilizing the voltage? That means here the GNR diode, which is the best example for the PN junction diode, you know pretty well. That means the diode is also here the diode which is also conduct the current in forward bias, and whereas in the case of reverse bias, the diode is not going to conduct any current at all. We know pretty well. So in case of GNR diode, breakdown voltage is to be noted, as well as the avalanche breakdown is also to be noted. So that's why here the Zener diode, which is to be used. Why? Because of the diode is not conduct any current at all in reverse bias condition. So the diode here in reverse bias not conduct current at all. Whatever the voltage is to be coming out. That means higher voltage is coming out, the diode is not conduct the current. When the lower voltage is also coming out, the diode is not going to be conduct any current. That means here in for stabilizing the voltage here, uh, in the case of stabilizers, the Zener diode which is to be utilized in the reverse bias condition. That means whatever the fluctuations which should be takes place here, the diode is not going to conduct current at all. Okay, that is to be noted here. That's why here you need to be use it the Zener diode, which is to be utilized as a regulator, voltage regulation. So, so what is the need for the voltage regulation, and what are the uses of the Zener diode, which is a voltage regulator, and what is the working of an electronic voltage regulator, and also how to calculate the percentage of regulation, and integrated circuit IC regulators, and also switch mode power supply. That means SMPS regulator. And you need to explain about the voltage regulator, and also how to design the maintenance of the output voltage at a constant, and also different types of regulators, which is namely Zener regulator, electronic regulator, switch mode regulator. Okay, different types are which are available for the voltage regulation. That means when there is a fluctuations, it is to be takes place. Fluctuations higher voltage or lower voltage. Continuously it is to be takes place. How to stabilize, how to get the constant voltage. That is called here regulated. So let us discuss about the introduction portion of this voltage regulation. So simple filters. That means a filter is it is to be remove the some of the AC pulses, ripples at the output along with the output DC. So these filters, which is discussed in the previous section, and which is cannot prevent the load voltage variations. Okay, due to the fluctuations in the AC main voltage, and also fluctuations in the load current. So to constant voltage drop across the reverse biased Zener diode. Please underline this word here, reverse biased Zener diode. That means the diode is not conducting any current at all when it is to be operated in the breakdown region. Okay, VZ breakdown region means breakdown voltage VZ, and avalanche breakdown is also there. Lightly doped, heavily doped. That is to be dependent upon the avalanche as well as the Zener breakdown. We already discussed that. So which is made use of the design of a Zener voltage regulator, that is nothing but a shunt regulator, shunt resistor, and also a transistor which is to be used as a voltage control resistor in series with the help of the power supply, and also a load in electronic regulator. So the series voltage regulator offers higher regulation without much voltage of power regulator. Why do you need voltage regulation here? So a cyclic variations, which is in the rectifier output, and also fluctuations in the AC main supply, 220 to 240 volts, then the frequency is 50 hertz, and the change in the load current. So here the filters, whether it is a pi filter, L filter, or C filter, whatever it may be, to minimize but cannot eliminate the output variation, voltage variation. Why? Because of the fluctuations in the AC voltage, main voltage, input main supply, and due to the variations in load current, and also electronic voltage regulations, which can efficiently maintain the rated output voltages in spite of the variations in the main supply voltage and the load current. And they also serve as a filters to certain extent, and how the regulator characteristics. So you can easily observe that from the figure only. An x-axis load current is to be considered, and y-axis load voltage is there, V naught. Okay. So here, what is the ideal power supply? That is a constant. But whereas the load current is to be increases, the load voltage, which is dropping here, that means the real power supply. Okay. By increasing the load current, the load voltage value, which is uh, decreases here. That means the real power supply value, which is to be decreases. Note it down this. So what is the percentage of the regulation here? V infinity minus VL divided by L into 100. This is the formula. VL, that is, what is VL here? VL is nothing but a voltage under load, and V infinity, that means infinity means OL, output voltage under no load condition, and this is the formula for that. And IL, which is to be expressed according to the Ohm's law, V equals to IR, and VL equals to IL into RL. Substitute the RL value, and the output resistance R naught of the regulator, which is VOC. What is OC? VOC means here open circuit voltage minus VL by IL. Therefore, percentage of the regulation is nothing but a R naught divided by RL into 100%. So for many given load current and regulation, which can improve the output resistance or internal impedance of the regulator, which is to be decreases. So hence a good regulator should have low internal impedance. Next, Zener voltage regulator. This is the most important question here. Yeah. Next, see the figure here. There is an unregulated voltage. Unregulated. So that is to be noted here, Vs. That is a signal voltage, AC main supply. Here a DC supply is there. Why? Because of batteries are there. So this is unregulated supply here, power supply. So the arrow mark, which is indicating that you can able to increase or decrease, variable. And plus is the length high. Longer one is the plus, and shorter one is the minus terminal of the battery. And there is a Vs, and across this there is pretty considerable signal resistance, the source resistance Rs. So that according to Ohm's law, V equals to IR, so I equals to V by R. That means Vs by Rs is nothing but a signal current, that is Is. Okay. So this is the Is signal current here. So here you can have, this is the symbolic representation of the Zener. You can see here. This is the Zener diode, Vz. The output, which is in the form of Z symbol. So if it is to be offered by a current, Zener current Iz, if there is Iz and RL, there should be Zener voltage, Vz is to be generated. And if it is to be passing through this load resistance, there is a load current IL, the load resistance is RL, then IL into RL is nothing but a VL. That means output is a regulated voltage. See here, left hand side is a unregulated by using only one single component, that is a Zener diode. The voltage is to be regulated, that is VL value. So by applying the Kirchhoff laws, IA equals to IZ plus IL, and so you need to do this calculation. Electronic regulator and also series regulator. So what are the figure which is there? So left hand side unregulated DC supply is there. We input at output section regulated DC supply. Only the thing is that resistor and Zener diode and also a IC, that means operational amplifier. Op amp is there 741, and a transistor is to be considered. Q is a transistor. 741 is a IC plus VCC and minus VCC. RZ, R1, R2, these are the resistors. RL is the load resistance. So that by using a Zener diode, op amp, and transistor along with the resistors, the voltage, unregulated voltage, it is to be regulated. Here also DC supply. So this is nothing but a electronic voltage regulator. And also another one is also there. Versatile variable voltage IC regulator, IC 720. So see here. Here also unregulated DC voltage is there at input section. Zener diode and also amplifier and different types of here resistors and capacitors, filters is there, and op amp is to be considered operational amplifier, and also two transistors is to be considered here. So that unregulated DC supply or the voltage, how it is to be regulated, the DC voltage, you can note it down. This is nothing but an internal schematic circuit of the LMIC 723 voltage regulator. That means this is a positive voltage regulator. So IC 7232, you can easily observe that 10 pins are there, and each and every pin, what is the pin which is to be noting? First pin inverting, and second pin is non-inverting. What is the fourth pin, fifth pin, third pin here? Where is the input here? Where to be considered the output? Sixth pin. VC1 is a VCC. Okay, so all these are there. So this is the diagram of positive voltage regulator. Next, fixed voltage IC regulator. So in this fixed voltage IC integrated circuit, so here also you can have input is there, output LM317, 713, this is, and two resistors, and how the output voltage to be regulated. That means a fixed positive voltage regulator. And this is about the fixed negative voltage regulator. What is the difference is there? This is a plus V in input voltage, and here minus input voltage. Okay, V in and V out, V in and V out. Two resistors are there. Here also two resistors. V out is to be there. Only the thing is that you have to change the whether it is a plus VCC or minus VCC. Depending upon that, you can easily notice that which one is the fixed positive voltage regulator, which one is the fixed negative voltage regulator. And also fixed 3-pin positive voltage regulator. Here also DC plus and minus unregulated voltage is there. Here a solid titanium capacitor C1 is to be considered in the input section, and 7-8 cross different types of ICs to be utilized, and another capacitor is to be considered C2 across the load resistance RL. How do you get the regulated DC output voltage, which is to be noted down? What is the output voltage? That's it. Only 3 pins, 1, 2, 3. How many pins are there? Okay, fixed 3-pin positive voltage. Next, this fixed negative voltage. Only the thing is that starting plus minus, convert this negative plus. So that is a fixed 3-pin negative voltage regulator. Next, what is switch mode regulator power supply, SMPS? So here, what are the limitations of this SMPS? The input step down transformer is bulky, and it is most expensive component because its operating frequency is low. Because of this low frequency, large value of filter capacitor which is to be required to decrease the ripples. Ripples means at output section along with the DC AC components present. So those are called ripples. How to remove the ripple? Filter is to be needed. So here in the case of regulator power supply, filters are not supposed to here utilized. That means these are not helpful for the case of this condition. So that's why you have to be using a different types of regulator power supplies. So what is the efficiency of this SMPS? Which is very low because of the difference between the input voltage and output voltage, which is very high. And this results a large power dissipation across the series pass transistors. And the linear mode power supply, which required additional plus or minus 15 volts DC source, which is to operate the active device like operational amplifier, and it may not be economically and practically feasible. And for a specified range of input and output variations, linear regulator which can maintain a constant output voltage, which is by dissipating, that means the dissipation across the series, which is the pass, very pass transistor. And here due to this dissipation, the excess power, which is a heat. So due to this reason, the linear regulator is suited for the medium current applications. So this is the circuit diagram. A rectifier is a step down AC input is there, rectifier and filter, and which is passing through the switching circuit. Again, it is to be switched on step down transformer and pass through the rectifier and filter. And a sampler is to be connected. A parallel amplifier is there, which is passing through the IC CL494, and there should be a triangular wave generated, and which is to be Sterling and logical circuit. If not, then again it just passes through the switching buffer supply. Okay, that is switching circuit. This is the block diagram of SMPS. You have to practice. What are the disadvantages of linear regulators? Here, the frequency is 50 Hz, not SO. That is 50 printing mistake, the step down transformer, and which is the first functional block, and which is a bulky and costly, and a large value of capacitors which is required to reduce the ripples, and input voltage which should be greater than the output voltage, and there is always a drop across the series element, and which is always in the accuracy. So due to this, power dissipated across the active devices, which is more, and hence the power transmitted to the load is less, which reduces the efficiency up to 25 to 50%. And what are the advantages of this SMPS? It does not require a step down transfer. Since the pass transistor is operated as a switch, the power dissipated across it negligible, and hence the power transmitted to the load is maximum. And this improve the efficiency to 70 to 90%. And you need to read out the theory of the SMPS and what are the comparison of linear power supply and SMPS. How the size, which is linear power supply is large, SMPS small. Weight is heavy and light, efficiency poor and good, operating task high low, noise level output low and high, maintenance transformer bulky small, filter capacitor bulky medium, transformer core laminated and ferrite core, regulation less than 0.1 and 0.3, RF interference stepped. That is a special shielding should be provided, and here there should be negligible. So what is the summary here? A GNR regulator and electronic regulator, which is gives a constant voltage output. Percentage of the regulation formula, you know that VOC divided minus VL by VL into IL. That is RL is IL into 100. And model questions. See here. Short question is a define voltage regulation and explain it. Discuss the action of the GNR regulation. And draw the circuit diagram of simple GNR voltage regulator. Explain it. And also SMPS, electronic regulator power supply. Explain its working. Okay. So you need to be understand this, and you need to be notice that what is the voltage regulation, how many types of regulations are there, how to do, how to practice it, how to remember all these things. So by coming class, this is the in this voltage regulations, you have expected questions is that here voltage regulation and explain with the help of the Zener diode, Zener voltage regulation. That is the most important as the question. And other important as a question is that the switching mode power supply SMPS. Okay, switching mode regulator power supply SMPS. So there is a short question is that what is voltage regulation? What is electronic volt regulation here? Like that they are going to be asking to you. So please aware of it. And by here, there should be a problematic questions which is to be asked to you. That is also to be, you have to practice that. So you must go for it and do the practice. And also here, uh, in the positive voltage regulator as well as the negative voltage regulator, and electronic positive as well as the negative. Okay, so all these, how to remember the electronic circuits here, you need to practice. And what is the block diagram of the SMPS also. Okay, so the most probably most of the students, by my experience, I am going to be saying that here. Uh, Everybody is going to be writing uh, here and drawing the circuits, but they are not going to be draw the proper diagrams here. Simply they are going to be writing and in different positions and different here. If there is a resistor, they are going to be noting that that is a transistor, like that. They are changing their names. So please be aware of that. And how to remember the circuit diagrams, you need to practice it. You need to draw 2 or 3 times so that you can easily identify. And there should be a simple logical difference is there to remember the circuit here. That is also to be here. We already discussed that. And if it is to be changing the positive terminal, if it is to be changing the negative terminal in the case of input section, how it is to be a positive and how it is to be a negative, uh, we already discussed that. You have only, the thing is that you have to practice. By practicing the circuit diagram, by drawing 2 or 3 times, you can easily remember that. Okay, so by coming class we will discuss about the what is that uh, here CRO, cathode ray oscilloscope. That is also in so only the thing is that you have to remember uh, that in one set there is a 3 sets are there, you know pretty well, ABC set. In A set, if the question is to be giving to you here Zener voltage regulation, somewhat you may expect that in C set here SMPS, like that. Okay, you can analyze that. Okay, na? So you, in first block or in first unit or second unit or whatever it may be, third unit, if the question is to be giving in the first unit, there is no repetition of the question in the second set also. Okay, so you may expect in the third set. Okay, this is a simple logic here. But if the question is to be giving to you, most of the 30% or the 25% of the questions which is to be repeated in A set as well as the C set, not in the B set. B set is the different. Okay, so you have to remember like that. So if you have any questions regarding this voltage regulations, you can ask me at any time at any cost. So by coming class, we will discuss the CRO, cathode ray oscilloscope, how it is to be working, and how what is the construction of the CRO, and where it is to be utilized here, and how the CRO and as well as the CRT, cathode ray tube, and cathode ray oscilloscope, how these are to be here functioning. So that we will discuss in the tomorrow's class. Okay.
Sir, would you please tell some important questions in the last class, sir?
Last class means, ma'am, which one?
Final class on 27th, sir.
26. 1 minute, ma'am. Wait a minute. 103. So these are the oscillations in unit 4. So you can have definitely one question is that here Barkhasan criteria. What is an oscillator? So in the case of a rectifier which can convert the pulsating AC into DC, that is a rectifier. But what about the oscillator? Oscillator which can convert the DC into a pulsating AC, direct current into a pulsating alternating current. There also it is to be how the oscillator which is to be do the oscillations means somewhat it has to be follow the one condition. That condition is that a when a beta equals to 1, a is the gain of the amplifier, beta is the gain of the feedback amplifier. When a beta equals to 1, then only the oscillator which is to be doing the oscillations. So this is the condition. So Barkhasan criteria, this is to be asked as a essay question. Next, Wayne bridge oscillator. That means two types of oscillators are there. Okay, our human our audible frequency oscillator and as well as the radio frequency oscillator. Audible frequency oscillators are RC coupled amplifier, RC oscillator, and Wayne bridge oscillator as well as the phase shift oscillator. So these are comes under the here RC combination. Okay, so these are the audible frequency oscillators. Audible frequency oscillators. So that out of these, definitely they are going to be asked as a Wayne bridge oscillator and also phase shift oscillator. Most important. Or else the short question is that Colpitt's oscillator and Hartley oscillator. These are the RF oscillators. RF means radio frequency oscillator, higher frequencies. So you cannot able to hear the frequency of these oscillators. That's why here, there only we are to be using here inductor and capacitors. In the case of Colpitt's oscillator as well as the Hartley oscillator, only one. What do you say? One inductor, two capacitors is Colpitt's, and two inductors on one capacitor is Hartley oscillator. Okay, are you able to hear this, Emma, Geeta?
Yes, sir.
Yeah. So like that you have to analyze. And one thing you have to remember that if the question is to be giving out from the unit 8 in oscillators, that means you have to divide that. That means in set A, there is a 3 sets are there for set A, B, C, like that. If set A, in set A, if the question is to be giving out from the oscillators, you need not to expect the same question which is to be repeated in the set B, or else the other question which is to be giving to the set B from the oscillators chapter. You can go for the other unit. Like that you have to analyze. Okay. So these are the important. What are those? RF and Wayne bridge or phase shift oscillator. RC oscillator. In this case, RC oscillator, Wayne bridge as well as the phase shift oscillator will come out. So out of these two, these are the two questions: Wayne bridge and the phase shift essay questions. Next, Colpitts and Hartley short questions. You have to explain all these things. You have to draw the circuit diagram and you have to derive the equation part. Yeah, Colpitts you can see here, capacitors and inductors. When you are using a inductor, you have to indirectly you have to say that that is a radio frequency. That means higher frequencies are there. You need not to hear those. Next, there are three types of multivibrators are there. One is that stable and monostable, bistable. Out of these three, damn sure one pakka essay question. A stable multivibrator, monostable multivibrator, and bistable multivibrator. Damn sure one essay it is to be asked. Next, schematic trigger, which is a short question, most important short. This question is asked so many times. Okay, that's it. From the unit
Okay, sir.
9. Unit 9. You need to practice the circuit diagram. And also, most of your friends and most of the students which are to be writing that here, they are going to be copying, and in the copying also refer the page number, textbook, and also refer the test series, block diagram like that. They are going to be writing easily. We are going to be identifying that this fellow is copied.
Yes, sir.
Next, block for power supplies and regulation. So today we discussed about the voltage regulation, and in the case of rectifiers and filters, only here whether it is a full wave rectifier or half wave rectifier or bridge rectifier. Out of these three, one question is to be given to you. That's
Okay,
it.
sir.
Okay. Right. By tomorrow's class, we will discuss about the CR or CRT,
Okay,
cathode ray
sir.
oscilloscope, like that. Okay.
Yes, sir.
Right. All the best.